In this variation on the parametric truss grasshopper definition, we're going to create a trichordal truss, starting from the basic definition of the parametric truss that we've created previously. And what we're going to be doing is adding a series of components that I've highlighted here in this group that will double the top chord, driven by a slider, so you can make the trichordal truss wider or narrower. Everything else about the parametric truss works exactly as it did before, the length, depth, etc., number of panels, all of that is exactly as it was before. One of the things that we're going to add then are a series of top crossbars using a quick set of 3 components here and just hijacking some of the data, and you can see those top crossbars a little bit highlighted in green here on the left, connecting the 2 new top chords. So this is the definition that we'll end up with. I have a screenshot available of this for you to look at, and we're going to work through this now step by step. So I'm going to open the previous grasshopper truss definition. You can see it here, functioning just fine. And make sure that you've completed this and that it is functioning just fine before you jump in to start doing something new. I'm going to actually take all of these components and move them down slightly to give myself some room to work at the top to add in some of the new components. But the first thing I'm going to do is actually reuse the depth slider that I created before by copying and pasting that and bringing it up to the top. I'm going to right click and I'm going to edit this to rename it width, but I'm going to keep the same limits and whatnot. So it's about the same as controlling the depth, only now we're going to be controlling the width. And what I need to do is to move the geometry for the top chord, which we created previously here, and make 2 copies of it that move equidistantly in the x direction, both positive and negative. So the first thing I'm going to do is put in a math component, a division, and I'm going to take one of my panel components that I made before, copy and paste that, and bring it up, and I'll zoom in. And we're going to take this and make it a number 2, so change the 1 to a 2. Hit OK. Remember, don't hit return. And I'm simply taking this width slider and I'm dividing it into 2 portions so that half of it will go in the positive x direction and the other will go in the negative x direction. So to give it those directions, I need unit vectors. I need x unit vectors, and I need 2 of them. And one of them is going to be reversed, so I could go ahead and just put in the reverse vector component. And these are going to give the direction and the magnitude for a move, so I can also put in the move component. So I can start to connect these up. The geometry that I'm going to move is the top chord, so I'll bring it up there for the geometry. And I'm going to be moving it first in the positive x direction, so connecting the division to the x vector and bringing that down, and it moves it once. And then I'll connect the other one up. And remember, holding shift, I get the direction vector in there twice. So if you look on the left, you can see that I have a new vector that now widens and narrows. I need to reconnect one thing. There we go. So I have 2 of them. They widen and narrow in an equidistant fashion. To be able to better visualize things, I'm going to come down here and I'll turn off the pipes for the top and bottom chord and the diagonals, just so that we can now see only the wireframe geometry on the left. And I'll zoom back here and we can now see that top chord moving back and forth. So now we're going to do some work with that. We're going to be actually substituting it for the places that the old top chord went, namely the divide and the pipe command. So I can take this geometry and first put it into the divide, and you'll notice what happens. the numbers, the point subdivisions switch, and we get our left and right diagonals working just as well as they did before. So that was easy. And we can move the sliders around to see that everything is connecting nicely, that it works when we change the length and make it shorter or longer. So this is a good, robust definition. Everything's moving and connecting very nicely. Before I start piping this up, or maybe I'll actually put some pipes back on there so you can visualize what we're going to do to add the top crossbars to this. So I'll take these two pipes. Mouse wheel click, and I will show them, and you'll see what's happening. The old top chord is still being piped. So the next thing that we'll do is substitute this pair of moved top chords in here for the top chord. We'll take the geometry, we'll hold shift and connect it in which case now all three top chords are being piped. I'll come to this pipe component and I'll right click on the input and I'll say disconnect. And what I'm disconnecting is, it goes off of the video screen, but it gives you choices. And I'm disconnecting the top chord SDL line while keeping the other two inputs. So we've now effectively created the new top chords and made the diagonals correctly connect to those. The only thing left to do is to create the crossbars that will be pipes based on lines that go from 0 to 0, 1 to 1, 2 to 2, etc. across the top. Before doing that, I'll show you something here that I've done in my definition, which is to group this new set of components. I can left click across them and again click mouse wheel and hit this little group icon, and that puts them into a group so that I can move them as a group. And I could also change the color if I want to, and I can put a name on those, and the way that that's done is with a component called Scribble. So just double clicking on the canvas, I'm typing in Scribble and I'm getting the Scribble, which gives you this double click me, double click that, and I can say something like double top chord. I can change the size of it, I can change the font, etc. I'm just going to leave it as it is, and I'm going to place it up here to make a note for myself so that I know what I'm doing right here. Now this can also be part of the group so that the text goes along with all these grouped things. Now that is a group with its tag, very useful for organizing your work. So the last thing we're going to do is add a series of crossbars, and to do that we're going to be working from this divide component, which gives the points that are going across. You can see the numbers in green across now the two top chords, and we're going to take those points and simply create a series of lines from 0 to 0, 1 to 1, 2 to 2, etc. It's just not quite as simple as you would think. If I put the line component in here, actually I'll not type it in. I'll go to curve, 2-point line, and I'll put that in here. And if I take these points and bring them up there and make those the beginning and the end of those lines, I should have a nice series of lines. Notice that nothing happens. So I need to start differentiating these to get them to work in sequence. And the way that we're going to do that, and I'll zoom in here, is to start putting in some list modifiers. The first one is going to be a flatten tree. So we're going to take the first of these lists and we're going to take it and run it through and flatten it. Now notice we do get a series of lines, and we get some of the ones that we want. We get the ones that go across from 0 to 0 and 1 to 1. But we also get a whole set of other combinations from 0 to 5, 1 to 5, 2 to 5, 3 to 5, 4 to 5, etc. That don't work well for us. And that's because the structure of the data coming in here is of two different kinds of data. So if you hover over the A, we get 12 values. If we hover over B, we get two lists, or we get a more complex data set coming in. And you can see that that's the case because the wire has a dashed line quality to it rather than a double line. So remember, a single line wire means that there's one kind of information flowing through it, just one piece of geometric information. A double line means that there's a list of two or more pieces of information, like we see when we hover over the A here. The dashed line means that you've got two sets of things coming through, and these are just not mixing well. So what we can do is add another modifier. In this case, it's going to be the shortest list. Shortest list component. And we're going to be using this to compare these two lists and to select the shorter of them. So I'm going to move this now from here. The flattened list is the first one. The original set of points is the second. And what this is doing is now comparing these, and it's outputting the shortest list. And so from the A, I'm going to bring that over. Notice that the wire has changed now to a dashed line, and I have exactly the same looking kind of data coming into this. They're not exactly the same. They are two different lists, but they have the same data format, which is creating now exactly the kind of set of lines that we want, from the 0 to the 0, 1 to 1, etc. And now we can take these and we can flow these into the pipe, holding down Shift, to the crossbar pipe, or the diagonals pipe. And so you can see them now clearly piped and responding to the slider for the crossbars. And we have the three chords responding to the slider for those. So our definition is all set, and it's working clearly. You can move some things around if you like, to not get wires to cross over each other. You can group things if you want and put names on them, which can be useful, as I did in the example that I showed you when I took these three in my screenshot and in the original example and made them in a little bit neater alignment, and then took all three of those and with the middle mouse wheel grouped them, and then with Scribble put a name on them, like create crossbars. And then I put that over here, and I can add that to the group. And I right click and I can add to group, and so now I've got these two elements all together in one group. So here is the trichordal truss, working very nicely and a very useful tool. Go ahead and save this with a unique name so that you have a basic truss definition, and you're going to want to save this as something uniquely named. I'm actually going to call this parametric truss trichord video, so that it's clear that this is the trichord that I made during the video creation. And so there it is. Go ahead and work with this. If you have problems, it's most likely just perhaps missing out on some of the nuances of flattening or shortening lists, but this should be pretty straightforward. Thank you.